Hi students, welcome back to my channel. In today's episode, we'll explore the number system and real numbers. When it comes to number systems, many of you might think that there's no need to study them. We use many numbers in our daily life, so they don't seem that special. In the following image, I'm sure many of you have seen similar diagrams in textbooks. They may look complex. The number system is not as complicated as you may think. Let's start with real numbers. These real numbers are the numbers we use in daily life. After that, we'll return to entire diagram. In this diagram, let's start from the innermost part. The innermost parts represent natural numbers. First, we need to understand what natural numbers are. Let's really learn about whole numbers, which include natural numbers. The relationship of whole number and natural number is that whole number include natural numbers, and integers include whole numbers and natural numbers. And the other set, rational numbers include integers, whole number, and natural numbers. You can imagine natural number is a small box. This small box is inside the bigger blocks. A bigger box is inside a bread, and the bread is inside a suitcase. Okay. Later we will study what the definition of these numbers and the relationship of them. On that side, we have irrational numbers. We have rational numbers and irrational numbers. Real numbers consist of rational numbers and irrational numbers. Real numbers are 1, 2, 3, 4, and so on. The term natural reflects that early humans used this set of numbers for counting, such as counting their belongings like sheep or pigs. Whole numbers include 0, 1, 2, 3. The number 0 become important when people began trading goods with one another. The only difference between natural numbers and whole number is the number 0. Whole number includes 0. In mathematical context, we say that natural number are a subset of whole numbers. Okay, we all know integers. Integers include positive integers, negative integers, and 0. It is important to look that 0 is neither positive nor negative. 0 is 0. Clearly, natural number are a subset of whole number, and whole number are a subset of integers. Okay, let's see some questions. Question 1, is 0 are positive integers or are negative integers? Is 0 an integers? Okay, you can see the diagram on top. 0 is neither positive nor negative. 0 is 0. Okay, so it's not a positive, it's not a negative. Is 0 an integer? Of course, yes, it is an integer. 2. What are non-negative integers? We can use the number 9. Non-negative, so we take away all the negative numbers. Okay, so the number remains 0, 1, 2, 3, 4, 5, and so on. Okay, they are non-negative integers. Question 3. What numbers are included in the set of non-zero integers? Okay, once again we use the number 9. Non-zero means that we take away the 0. Okay, so what are the non-zero integers? They are negative 3, negative 2, negative 1, and over 0, 1, 2, 3, and so on. Okay, which numbers are integers? Perhaps we need to use a calculator. Square root of 4 is 2. The square root of root h is 2.h2h. And this square root is 81. And you can check the square root of negative 25. It will give you the message error. Okay, so in this case, we can say that wood 4 and wood 6561 are integers. Move to the larger set of number, rational numbers. Rational numbers are defined as numbers that can be expressed in the form P over Q, where P and Q are integers and Q is not equal to 0. In this context, rational numbers include 3 types of numbers. The first type is terminating decimals. These are examples. They can be expressed in the form P over Q. For example, 0.375 is equal to 375 over 1000. 1.28974 is equal to 1.28974 over 100,000. Okay, all terminating decimals are rational numbers. The second type is all integers. For example, 4. 4 is an integer, but it also can be expressed as 4 over 1. Okay, so all integers are rational numbers. Okay, the last type is recurrent decimals like 0.4 and 0.13 and 1.4, and there are some dots over the top of the number. 0.4 dot means that 4 repeat. Okay, so it is equal to 0.4444 without n. 2 dots over 1 and 3 means that 1 3 repeat. So it is equal to 0.12131313. The 1 3 repeat. Okay, the last one 1.04. There's only 1 dot over 4. That means that 4 repeat, but not 0. Okay, so that's equal to 1.04444 and so on. It can be shown that 0.4 dot is equal to 4 over 9. 0.13 dot dot is equal to 13 over 99. The last recurrent decimal is equal to 1 and 2 over 14. The method for converting recurrent decimal to a fractions will be covered in the next episode. In contrast, irrational numbers are numbers that could not be expressed in the form of P over Q. Please note that irrational numbers are later. Irrational numbers were discovered around 300 BC. There are some examples of irrational numbers like pi, root 5 and sine 21 degree. You can use a calculator to check the value of these numbers. They are all decimal without n. Okay, let's do an exercise. Determine whether the following items are rational numbers or irrational numbers. Okay, the definition of rational number is that they can be expressed in the form P over Q. Okay, we can check which one can be expressed in the form of P over Q, but instead we have another way. So we are going to check these 10 numbers by using these classifications. The first 2 are integers, so these 2 they are rational numbers. Root 10 you can check by your calculator is equal to 3.16 so and so without n, so it is irrational numbers. Root 25 over 9 is equal to 5 over 9, so of course it is a rational number. Okay, number 5, root 36 minus root 11, okay, is equal to 6 minus root 11 is a decimal without n. Okay, so for this number is a irrational number. Okay, number 6. The numerator is 7, denominator is 4 plus 2, so 7 over 6. So it is in the form of P over Q, so it is a rational number. Okay, question 7. Root 2 minus 1 square. We need to explain the bracket and see whether it is in the form of P over Q. Okay, it is equal to 2 minus 2 root 2 plus 1. So 3 minus 2 root 2. So you can see that the root 2 is an irrational number. So the whole thing is irrational number. It's an irrational number. Okay, number 8. 2 plus root 3 times 2 minus root 3 is equal to 4 minus 3. Okay, a square minus b square is equal to 1. So it is rational numbers. Okay, number 9. Cosine 60 degree. It is a special angle. Okay, cosine 60 degree. I hope you remember this value is equal to 1 over 2. So it is a rational number. Okay, the last 0.7 dot. Okay, because it is a recurrent decimals, so it is a rational number. In last questions, consider these numbers. Write down all the integers, rational numbers, and irrational numbers. Okay, perhaps we need to simplify some of the numbers. Okay, now this numbers is equal to 2 times 4, which is equal to 8. And 30 degree and 45 degree are special angles. This one is equal to 1 over 2. Cosine 45 degree is equal to root 2 over 2. Okay, part A, write down all the integers. Integers include negative 3 and 2 root 16 and no more. Okay, part B, write down all the rational numbers. Okay, rational number, negative root 3 is a rational number. It is an integer. Next one is 2 root 16 because it is an integer. 4.3 is a terminating decimal. Okay, sine 30 degree. Okay, itself is a fraction. 45 is also a fraction, but on the top, root 2 is not a rational number, so cosine 45 degree should be irrational numbers. And the last one, 1.4 dot, is a recurrent decimals, so it is rational numbers. Okay, part C, write down all the irrational numbers. Please look that all numbers are either rational or irrational, so the remaining number are all irrational numbers. They are pi, root 5, cosine 45 degree. Okay, in this episode we have learned real numbers, but at the same time, on the other side, there are some imaginary numbers, and combine these two things, we have complex number. So the learning of number system is not complete. Complex numbers will be covered in the later episode. Okay, see you next time. Bye bye.